Hello and welcome to Problem Solvers, brought to you from the museums of the University of St Andrews. My name's Matt. Every month we will look at a problem solver from the past and give you a problem facing people today for you to solve. What? The picture behind me is upside down. Problem solved. Now today we're going to find out about James Irvine. He was a chemist at the University of St Andrews between 1909 and 1952. Now, a chemist isn't just the person you go and get medicine off when you're sick, but more about that later. James's problem was this. What does sugar look like? Well, that's simple, right? It looks like this. Well, yes, but it also looks like this. These are different types of sugar that Irvine collected, and they look pretty different, don't they? You see, there's actually lots of different types of sugar, and not just the type that you put in your tea. Sugar comes in sugar cane, but also in fruit, vegetables, and in plants. In fact, Irvine collected 900 samples of sugar. My kitchen isn't big enough for them all. But Irvine wasn't interested in whether sugar is white or brown or even orange. He was interested in what sugar looks like when you zoom in really, really close. You see, sugar is made up of molecules. Molecules are like tiny bricks. Everything in the world is made up of them. The things we see and many of the things that we can't see, like air. A chemist, like James Irvine, is someone who investigates different materials and the molecules that make them up, how we can change them, how we can mix them, how we can use them. So Irvine's problem, what do sugars look like? Well, they all look different. The molecules, those tiny bricks, are arranged in different ways in different sugars. So one sugar might have the bricks arranged like a bungalow, another might have them arranged like a castle. Actually, scientists often make models to see what those molecules look like. These are how those molecules are arranged in one type of sugar called fructose. And this is how they're arranged in another type of sugar called glucose. But Irvine had another problem. How do you get some of these sugars? Some sugars are attached to other sugars, and he needed to separate them. And he needed to get other sugars out of the plants they were part of. In fact, during the First World War, he needed to get sugar out of a plant called a dahlia in order to make medicine for troops in Turkey. But how was he going to get all these dahlias? He put an advertisement in a national newspaper, and so many arrived at the train station in St Andrews that he had to get the local Boy Scouts to help him carry them. So Irvine was a great problem solver. But what about you? Can you solve a chemistry problem? Here I have 3 different colours of water. But what happens if I mix them together? Well, they make a kind of mucky brown sludge. The problem I'd like you to solve this month is to mix those colours of water together, but keep them separate in stripes, a bit like a rainbow, not brown like this. And here's a clue, just like Irvine, you'll need to use sugar. Have a go at home, send us your photographs if you manage to do it to museumlearning@st-andrews.ac.uk, and next month we'll show you how to do it. Now I'd like to introduce you to a friend of mine, a real life chemist called Yi Ying, and she's going to set you another problem to solve this month. Hello Yi Ying, how are you?
Good, how are you?
Not too bad, thank you. Now, Yi Ying, you are a chemist. Can you tell us why you like chemistry and how you started doing it?
I remember one of an experiments I have done in my high school. My chemist teacher, he stirred salt and sugar into a glass of water. Then he asked us to separate the salt and the sugar. At the time, it's a pretty challenging question, so my group designed an experiment to separate the salt and the sugar. Of course, after that, we need to check they are salt and sugar. We failed several times, but every time we failed, we trying to discuss and come up with new ideas, and finally we succeed. And I think that is why experiments are so fascinating and I enjoy it. And this is the main reason I choose to study in chemistry.
So it's all because of your school teachers.
Yes.
And now you do experiments in chemistry at the University of St Andrews, and you work with a material called graphene. What is graphene and where can we find it?
So this is a pencil, but do you know what's the material inside the pencil?
Is it graphene?
Well, pretty close, but it is graphite, and graphene is a layer of graphite.
Ah.
So it's pretty thin, but I will give you an example to let you know how thin it is. So it is 1,000,000 times thinner than a human hair.
Wow.
Well, it's still hard to imagine, right? Yeah, and I have a easy way to produce graphene. Let me show you. This is a Scotch tape, and on the tape you can see some layers of graphite. And if we use the other Scotch tape to peel off layers of graphite, keep repeating this process, at one point we can have our graphene. And you can see from this Scotch tape, there's some, like, the colors is changing to transparent. This is because the graphite layer become lesser and lesser. Because graphene is transparent, so we cannot use human eyes to do the research. We need to transfer the graphene onto a surface and use microscope to do the research.
So the fact that graphene is really thin must mean that it's also really light and therefore really useful. So what are you trying to do with graphene?
So I would like to make long strips of graphene. We call it graphene nanoribbons. There are many methods to do that. One easy method is to cut graphene into pieces. This is the structure of graphene, but you can see it is a honeycomb structure. But it is really hard to control its age if you want to cut it into pieces. So I use the other method, which is pretty much like playing Lego. So I designed my own building block and then I heat it up so they can link into graphene nanoribbons. And this is my building block and this is my ribbons.
So it's like having two Lego bricks and you stick them together with heat.
Exactly.
Excellent. And why on earth do you want to do that? Why do you want to create strips of graphene molecules?
So, as mentioned, graphene is very thin and very light. We all know that we use copper as wire, but graphene is better than copper. So we can use graphene in mobile. And this is my mobile. But you can see it's very heavy and it's very thick. It might be a little bit exaggerated, but if this is my mobile phone, it's very light and thin. You can even fold it and put it into your pocket.
Wow. So these strips of graphene molecules allow us to have really thin, light, even foldable mobile phones.
Yes, in the future.
Wow, amazing. Yi-Ying, thank you very much for talking to us.
Thank you.
So the problem that Yi-Ying wants you to solve is to design a machine that can stick these graphene molecules together to make the strips. You can send us a model, a drawing, or just explain how it would work. And remember, the molecules are a bit like Lego bricks that are stuck together using heat. Send your ideas to museumlearning@st-andrews.ac.uk, and next month Yi-Ying will have a look at your ideas and tell you how she does it. See you next month.